We have that a mail carrier delivers packages to the 4-block neighborhood pictured below. As the streets on the outside of the neighborhood only have houses on one side, she'll have to walk them only once, while the roads on the inside will need to be walked twice to cover each side of the road. What we want to do here is draw a graph to model her route, using vertices to represent intersections and edges to represent streets. And we're going to do the same sort of thing that we did in that last one. We're going to take that idea with the map and flatten it out a little bit and start abstracting in terms of where the intersections are, then take away all of those pieces that we have the intersections at, take away all of that information, and just leave ourselves with the vertices representing each of those spots, and then where they need to be gone between, because you're going around the outside, you get one edge along the outside of the box, and then on the insides, you get two each for the fact that they have to be walked twice. So if we want to think about what kind of graph this would be in that language of simplicity that I talked about earlier, this would not be a simple graph. Again, not super important, but I do want to at least hint at some of these other things that are going on here, where in particular, this kind of problem of using a graph to talk about a logistical issue of someone trying to make deliveries or pick things up or follow someone around, or whatever you have there, that hints at ideas called traveling salesman problems and shortest path problems, which are things that we are going to get into later and that I in particular have done research in the past. Just a bit of my context there as well, so that you know. And the next thing we're going to look at here is a bit more into the depth of the notation we have. We're going to talk about what it means when something like that vertex there in the bottom right corner is connected by edges to two others. How we discuss how many things are connected and what it's connected to in terms of language like adjacencies and in particular degrees of vertices.